Lesson 8 is on rational exponents. This is actually, it's not specifically in this unit. It's just some work that we need to do to prepare for the next lesson in the unit. And actually, we probably should have done it at the beginning because this is one of those things I've said, oh, we're going to do that later, and you've had a few problems come up. So hindsight, I would have moved it earlier on in the lesson. But we're going to talk about rational exponents and radicals. So a little bit anatomy of a radical. If we have a root, right, this symbol is called a radical, and we have a number up here, which is called the index. And most often the ones that you've seen haven't had a number there because they are just a 2. The index is a 2, which means it's a square root. And then you have some number inside, which is called the radicand. So this root number tells you how many times you have to multiply something to get the number inside. So for example, if we have the square root or the second root of 16, that is asking you, what number do I multiply 2 times? This tells you how many times you multiply a number, and then it has to equal 16. If I had a third root, I'm kind of encroaching on this other area here now. If I had a third root, that would say I need to find some number that I multiply by itself 3 times to get 8. So the index tells you how many times you are multiplying a number, and then the radicand is what you're trying to get it to equal. Your answer, your simplified answer, is what is that number? So in this case, it would be a 4, right? Because if I multiply 4 by itself, 2 of them, that would get me my 16. For this one, it would be 2, because I can multiply 3 2's to equal 8. We've also done problems with the square roots where it didn't come out to be a whole number and we had to simplify them. So we're going to see what that looks like today with a different index also. But before we get to that, we're going to talk about a rational exponent. Rational just means fraction. So when we have an exponent that is a fraction, the power is the numerator, that means the top. So the top number is the exponent, and the index or root is the denominator, which is the bottom number. So I just keep saying power over root, power over root. We're going to convert these into roots. So instead of having a fraction exponent, we're going to write it as a root. The top number is the power. The bottom number is the index or the root. So we would write the top. So we're going to write a root. The bottom number is the root or index. So n. The top number is the power or exponent. The x is the number that goes inside. You can write your power in here. So you could put an m in here, or you could put it like outside of all of it. You're going to get the same thing either way. So you could put an m in here or an m out here. Both are exactly the same. Okay, so our first examples, we're just going to practice going back and forth, kind of like we did with exponential form and log form, is we first just have to know how to manipulate them back and forth. So here we have an x with a rational or fraction exponent we want to rewrite. So power over root. Top number is the power, the bottom number is the root. So it's the 5th root of x, and then 4 is the power. So again, you can put a 4 in here. You could put the 4 out here. It doesn't matter where your power goes. So I'll do one way and one the other. Power over root. Top number is the power. Bottom number is the root. So 5th root of y to the 3rd. So this one I'll put the power on the outside. Maybe put a note to yourself. It does not matter. You can do what you like. The next two, we're just going to do the opposite. So here they are written as radicals, and we want to convert them to a rational or fraction exponent. So 5, what am I saying? X to the power over root. So we're going to have a fraction exponent. The power goes on top. So 5, the root goes on the bottom, over 3. Here we have one that doesn't have any numbers at all. So we're expected to know what those numbers are if they aren't there. If they're in, it's kind of hard, right? Because they're all different rules. Like, on a logarithm, if there's no number written, it's a 10. In an exponent, if there's no number written, it's a 1. And in a root, if there's no number written, you need to know it's a 2. So these are all just things that we have to memorize. So if you don't have an exponent, remember it's a 1. If there is no index, it's automatically a 2. So when I convert this, it's a to the fraction exponent power over root. So the power is 1 over the root is 2. So when we're evaluating, like this is tougher to evaluate, like for us to do it by hand or mentally. It's a lot easier for us to think about square roots because we know kind of what those mean. We're a little more familiar with that. Okay, so now we're going to simplify some radicals. We're building up to we're going to solve them, but remember today is just like practice, kind of going back and forth and getting familiar with them. So now we're going to simplify some radicals. So we're going to break them down into prime numbers. We did this earlier in the year. If you were with me, we did the birthday cake. If you were with Mrs. Wood, she does the factor tree. It doesn't matter. Pick something you like. It does not matter what you do. But we're going to rewrite as a radical and then simplify if possible. So for this first one, we are going to do 25 goes inside power over root. So 3 is the power, 2 is the root. Sometimes they come out to be whole numbers and you can just do them on your own. This one, we could do 25 to the third, but without my calculator, I don't know what that is. I do, however, know that the square root of 25 is 5. So you can do either first, either the exponent first or the root first. I'm going to do the root because I can do mental math then. Square root of 25 is 5. And then I'm going to do the power. 5 to the third is 125. Okay, so convert it first and then see if you can simplify. This one, we actually have a little issue here because we have 2 different exponents. So we're revealing a power or a property here that we haven't done for a while. If you have one base with 2 exponents, then you multiply the exponents. So we get 32 to the 3/5 power. So we're going to write it as a radical. 32 goes inside. Power is 3 over root is 5. Again, I could do 32 to the third and then find the 5th root. I don't know what that is. I can do the 5th root mentally. The 5th root means some number that I multiply 5 times. 1, 2, 3, 4, 5 that equals 32. I happen to know that that's 2, right? Or I could like multiply it out and figure out that it's 2. If you don't, you need to find that 5th root button on your calculator. I have that Texas Instrument, that blue one that so many people have, and mine is above the caret, and it looks like this. I'm not exactly sure what order you do it in. I think you do 5, and then this, and then the 32. Play around with it and figure out how you can get it to equal 2. If nothing else, then ask me in class, and we'll look at your calculator together. So the 5th root of 32, a number that I multiply 5 times to get 32, that's 2. And then I can cube that and get 8. So these have all come out nice, right? No, nothing weird. They're all nice whole numbers. What if they don't? Because they don't sometimes. So we're going to do 54 in the root to the power is 1, root is 3. Okay. There is no number that I multiply 3 times that gets me to 54. That doesn't work. So I have to start breaking it down. Again, you can do the tree if you like it, or if you want to do the birthday cake. So I'm going to do a little review of the birthday cake for those who were not with us. Okay, birthday cake. We're going to set up like a division problem, right? 54, we're breaking down 54 into prime numbers. Do the little division sign. The smallest number that goes into 54, that's of course not 1. The smallest number that goes into 54 is 2, right? 54 divided by 2 is 27. That's just a division, like how you'd set up a long division problem. 54 divided by 2 is 27. Then we're going to do it again. 27 is divisible by the smallest number that goes into 27, that's not 1, is 3. So I'm trying to cover it with my hand. We're covering up this part now. We have a new problem. 27 divided by 3 is 9. 9 is divisible by 3, and we get 3. 3 is divisible by only 3, and we get 1. So the whole point of birthday cake is to get a 1 up here, and that's like your candle. See how this kind of looks like a layered cake, right? Here's your prime factorization. I love birthday cake. It gets all lined up perfectly. It's nice and straight. It kind of appeals to me instead of factor trees where you have things everywhere. Okay, so when we were doing square roots earlier in the year, you were looking for pairs of 2. And every time you saw a pair of 2, that number came out of the radical. Now, because our index is 3, that means what number do you multiply 3 times? That means it takes 3 to come out of the radical. Every time I have 3 of something, that number can come out of the radical. So that's now out in front, out here. This 2, there's not 3 of them, so I don't have enough to bring it out of the radical. That means that it is left over inside. Anything left inside, or anything left over without a group, has to stay inside. And then our last one of these, again, I'm going to rewrite it first. So 4 goes in the root. Power is 3 over root is 4. So what number do I multiply by itself 4 times to equal 4? There is no whole number. It doesn't come out to be a whole number. You could do a decimal or a radical. Because if I did 1 times 1 times 1 times 1 still is 1. If I did 2 times 2 times 2, that's 16. So it doesn't work. And remember, the directions said simplify if possible. This one doesn't simplify any further, so this would be your final answer. Okay, one last little section, which is a little bit of solving. We're going to do it when it's actual square roots in lesson 9, but a little bit of solving. So we talked about in class the other day that whatever we're trying to solve, whether it was the exponential or the logarithm or radicals, you want to get that thing by itself first. So in this case, this x that we're trying to solve for with its exponent, we want to isolate that first. We want to move everything else to the other side first. So in this case, I would divide both sides by 2. So I'm going to divide by 2, get x to the 1/3 equals 16 divided by 2 is 8. Let's fix that. 1/3. Okay, so then we're going to write it as a radical. I did one step before this. We're going to write it as a radical. So x goes on the inside, draw my root. Power is 1, so I don't really need that. Root is 3, and that is equal to 8. So if we want to solve radicals, we need to do the opposite. So if this is a third root, to cancel it out, the opposite The opposite of a third root is the third power. Roots and exponents are inverses. They are opposites. So to cancel a third root, we use the third power. And if I do it on this side, then I have to balance it out by doing it on the other side as well. So these cancel, and I just have x equals, and then on the other side, 8 to the third is 512. So let's try one more. This time, all of this is in parentheses. So this whole thing has the exponent. So I'm going to isolate all of this by moving the 3 to the other side. So I have x plus 1 to the 1/2. Keeps doing that. And we're going to subtract 3 from both sides. So it equals 2. Once that part with the fraction exponent, the rational exponent, is isolated, once you get that alone, convert it to a radical. So I'm going to put a radical. All the stuff in parentheses goes inside. The exponent is a 1, so I don't really need it because you don't care about an exponent of 1. The root is a 2. Equals 2. Okay, I'm trying to get x by itself, so I need to get all this other stuff away from it, so I'm left with just an x. And the 1 is inside, so you can't move the 1 right now because it's inside here. It's stuck in there. So I need to get rid of that root first. It is a square root. So the opposite of taking a square root or a second root is to do the second power. And then to balance it, we do the same on the other side. So second root, second power are opposites. They undo each other, and I'm just left with x plus 1 equals, and then on the right-hand side, 2 squared is 4. Now if there's anything left after that was inside with the x, now that you've gotten rid of the radical, you can complete your solving. So subtract 1 from both sides, and x equals 3.